So how long has this community been? يعني بتذكر بس الحكي لي بس نسيت.
نحن بلشنا
من ايمتى صار في هذا الشيء؟
هلا هذا الشيء اول مره.
هذا الشيء اول مره انه يميت ان بيرسون. اوكي ما في فيزا ما في شيء هيك انه بالمناسبه المفروض نعمل ايفنت تكون مبين انه
مره
باقي مرة الجاي. اوكي.
نحن صرنا 4 weeks.
4 weeks. قلت لي يعني حسب ما فهمت you're going over the advanced course معك تبع machine learning specialization course 1.
خلصنا اول واحد.
هو كله 4 weeks صح؟ يعني عم
3 weeks.
هو 3 weeks.
بس اول ويك كنت مثل انه عم نخبر شو بدنا نعمل.
وكلها اسynchronous اونلاين؟
ايه بس هلا من هالاسبوع حنبلش اون كامبس.
اون كامبس؟ ان شاء الله.
ان شاء الله.
Good. So كلكم خلصتوا the first course of advanced specialization. مين لقي فيه صعوبة؟ كلكم فاهمينه كلكم completely. عم بتذكر وين بيخلص أول course. I remember you at least know the language of machine learning. اللي هي what are the types of machine learning? Supervised, unsupervised. So بتعرفوا what these mean at least, right? And you also know about certain problems within each type. Supervised showing the tasks that we usually do. Regression, classification, شو الفرق؟
Regression continuous set now.
So the type of task is determined حسب the output that we're predicting, right? So it's either in regression it's a continuous number, a real number. In classification, finite discrete and known ahead of time. يعني the values that we know. هذه شو عم تطورنا؟ المفروض تاخذ معي consent قبل. اسألني.
فينا نصور؟
ايه. بس لأنه يعني حدا ثاني could lead to issues. Good. So هول the two most common tasks صراحة. يعني most of the things you see are applications of either regression or classification. Most of the things you see online, could media hype stuff, fall under supervised learning using data. If you work in the unsupervised space that you haven't yet learned about, but do you know what these are? تعرفوا شو applications من unsupervised learning?
Anomaly detection.
Anomaly detection. Okay.
Fraud detection.
Fraud detection. How is that unsupervised? Fraud detection can be thought of as anomaly detection. So they're thinking of fraudulent transactions as anomalies. They can be thought of as supervised learning. What are we classifying whether it's a fraudulent transaction or not? So usually fraud detection is actor under the supervised learning.
هلا أنا بالانترنشيب تاعي كنت unsupervised.
بالانترنشيب تاعتك كانت unsupervised يعني what algorithm did you use?
دي بي سكان. مش بس دي بي سكان بس إنه كان في دي بي سكان.
What was the output يعني you were going for?
عم نلاقي groups of fraudsters.
So هذا اللي كان اسمه يعني in unsupervised learning what we do, one of the things we do is we cluster. معنا data بس ما بنعرف عنها شيء. We don't have a certain pattern that exists. We try to learn is that certain groups exist, and then نصير نطلع كل group representative. So it's a completely different story than the supervised learning, where we have ليه اسمها supervised. We know the right answer to the question we're asking, so we can supervise the learning process of the agent. That's what we're supervising. We can act as supervisors in this case. أنا عم بفتح هون يعني I'm gonna have some slides ahead of me. بس أنا أقول بس يعني this is the way I imagine this is as an informal session. I know nothing about this says informal. يعني مبين the classroom setting. لازم شي conference room or some other. يعني I want you all to participate. I want you to ask questions. I want to know what's on your mind, what you'd like to get out of this community. يعني إن شاء الله بضل هيك يعني and growth even more across campus and next time يكون في more majors involved, especially non-technical ones and في كثير collaborations and the bottom line in all of this machine learning space is that it's data driven. So anywhere there is data, there is interest, and you might find yourselves working in areas that are completely foreign to you. هلا نحكي شوي عن applications outside of technical majors. But I do have some slides that we can look at and back they inspire discussions and questions. The slides are not in the presentation over the years, so I think you will be able to tell once you look at them. All right. So today, since you're learning about machine learning on Coursera, I don't want to repeat things for you or reinvent the wheel or say things you will be hearing anyway. So I will try to bridge the course you've already seen with what's to come. خلصنا course 1, هلا في course 2 which I think we'll talk about ensemble methods, this is 3 based algorithms. This is the thing to have in mind, and neural networks as the more important part of the course. So I'll say a bit about that, and then I'll open the floor to any questions you have and other things. كمان نحكي شوي عن the history of artificial intelligence. So the term AI, who can define what's AI? What's artificial intelligence? هلا إذا بسأل كل حدا يمكن كل حدا يطلع معه definition يعني it would be a good exercise. But if someone wants to take a chance, can someone tell me what AI is?
Make a copy of human intelligence.
Make a copy of human intelligence. Good. مش ضروري make a copy بس an attempt to replicate human intelligence, right? And this is إلا كذا approach. Okay.
في كذا method يعني.
شو هن؟
فيها تكون على simple tasks. إنه
sorting or ranking or
مثلا الماشين تقدر تعمل task فيها تكون
this is the newer definition, Elizabeth. So you're both right. But originally, whenever we used to say, هلا صار في عندنا difference with terms. Why am I saying this? And I personally find it confusing. People use these terms interchangeably all the time. I have no idea what they mean. And when they say something, بيكون قصدهم شيء ثاني. Generally, when we said artificial intelligence, the goal was to replicate human intelligence. So humans do things well, so why not try to replicate that on a machine? هلا that field of research still exists, بس زادوا حطوا كلمة G. So general artificial intelligence, right? So it's GAI. هذا ال G مستحدث. And then the new kind of AI, most of the time when people say AI, بيكون قصدهم machine learning, which is what you described. اللي هي more focused set of tasks that are more practical with a clear goal in mind that we can drive towards. Usually بتشوفوا these, I don't know if you've seen this, but artificial intelligence includes machine learning. Most of the work and the research and applications are in the machine learning space. في other algorithms, في other attempts, في rule-based methods مثلا منهم data-driven that go back لورا. And then as a subset of machine learning شيء اسمه deep learning as well. Some people إذا بدكم تحطوهم كلهم على السي في بينوا اختار هي شغلة واحدة usually. When you say machine learning, it should encompass all of these. Does anyone know what deep learning is? سمعتوا الترم؟ It's machine learning using a certain type of algorithm. كيف؟ شفتوا هلا logistic regression linear regression. All right? When I'm teaching the course, وصل محل semester I tell students assume these are the only algorithms that exist. And there's a lot of things you should know that are independent of algorithms. That have to do with data preparation, cleanup, how to deal with missing values, things like that. And then we can learn the rest of the algorithms اللي حتشوفون the second course. So deep learning is simply an application of machine learning using a certain type of algorithm اللي هو artificial neural networks. So بطل حدا يقول artificial and we're assuming we're not using actual brain matter. So the concept of artificial intelligence isn't, even though it's booming, it's a hot topic, people are talking about it, especially with ChatGPT وغيره. But these ideas are well documented in the from the 18th century. There has been evidence of trying to replicate human intelligence on a machine. Have you seen this somewhere? This was supposed to be a chess-playing machine, automatically chess-playing machine, يعني a robot. طلعت hopes في الأخير يعني a guy used to hide in this compartment and move the pieces. But it was advertised, at least in the beginning, as a machine that would think for itself and perform chess moves. And that's why chess is associated with intelligence. So one of the first spaces whenever we want to apply these algorithms is these games. في واحدة أصعب من chess. هذا بيعرف شو؟
Chinese chess.
Go. كمان it made the news in AI. That's why I'm asking. لأنه chess, even though it's difficult, Go has even more spaces and configurations. So the expectations were, even though we have computer programs that play chess well, go بعدها safe for humans. Until Google changed that. They created a program that beat the world champion in Go مرة بعد مرة. Anyway, so some history, some more recent history. How did this idea of artificial intelligence on a computer come into place? The ideas we use now go back to as early as 1943. And it was inspired by biological advancements. And some research in neuroscience shed light on how human brains work. So now after okay, it's made of neurons. These are a type of cells that are connected to each other. And the connection of neurons differs. Some connections are stronger than others. And it seemed that we translate that into some mechanistic framework, some model that's artificial. If that's all a neuron does, if that's what the brain is made of, let's try to replicate it on a machine. So that initial inspiration was biological. But I want to emphasize the similarities almost stop there. People like to think that what we're doing in artificial neural networks really follow closely how brains work. I don't think that's the case anymore for multiple reasons. The first reason is we have no idea how brains work. In neuroscience متفقين بين بعض يعني كل فتره بغير الراي انه بيطلع اكتشاف بيطلع اكتشاف عكسه. It's still a mystery. I don't think we've cracked the mystery of human intelligence yet. And that's why the definitions that say AI replicate human intelligence. What's that? Let's understand what this does before we try to replicate it. There are so many question marks in that space. Is a for neuroscience to figure out how humans do what they do. I think that the pace would have been slower. So even though the initial inspiration was closely related, eventually things diverged. It started after statistical, mathematical, more focused, machine learning. But this was again back in 1943. Imagine how old ago it was. The point I'm trying to make with this is what took it so long. Can anyone guess? Is that أفكار ما جديدة. And if it's an algorithm that's goes back decades. يعني مثلا بعد الحرب العالميه الثانيه عم بتصير اذا تشوفوا دوكيومنتريز بالاسود وبالابيض من وقتها كانوا عم يحكوا ب artificial neurons. So why are we only hearing about it now? ما كان في so hardware limitations are one factor. Computational power is related to hardware. Computational power is measured by what kind of processors do we have to support that kind of thing. Data. So data was not as available. It was much more limited. In 1943 ما حدا كان يسجل شيء بعده. So these are definitely the two main factors that are driving the success of machine learning in this day and age. And I'll talk more about the actual turning point in my opinion. And what happened so that we got to where we are now. Do you know this guy? حاضرين the Imitation Game? It's a good movie. Watch it if you haven't. Do you know the Turing test? Can someone tell me who doesn't know the Turing test? Okay, significant number. So this was proposed by Alan Turing to. Okay, so they started talking about artificial intelligence on computers من وقتها. And the question came up, how do we know if we actually create that? We need to know. We need to assess our success in that story. So the first this was one of the first tests proposed, which said if we can have a conversation with a machine and not be sure about whether it's a machine or a human, then we can think that this machine is intelligent. So the test is as follows: a human subject would be having a conversation through a screen with either another human subject or a machine. We wouldn't tell subject C here. And if subject C could tell the difference, then this machine fails. Otherwise, if the subject C was confused and could not really tell whether it's a machine or a human on the other end, then we say that this machine successfully deceived this subject. So it actually has the intelligence needed. There are so many issues with this test. Obviously, as I have it with ChatGPT, it might. Who thinks it will pass? Would it fail?
حسب.
دغري بتعرف ChatGPT. هلا انا دغري بعرف اذا وصل لي ايميل من تلاميذ using ChatGPT. It's obvious. أصلاً بيكون هالقط طول. Usually students don't write such long emails. ChatGPT likes to write. حسب how you prompt it صح؟ بس هلا with prompt engineering you can actually direct ChatGPT to sound like a هو ما بعرف you should do this مثلا write an email as an 18-year-old undergraduate تعملوها وتحط okay you should be specific when asking يعني for that otherwise كله نفس الشيء بيطلع لك بصير نفتش على انه شو what's the question بالضبط بالنص هذا لازم يشتغل عليها هي وقصه I hope ما بعرف نبلشها I hope this email finds you well يعني ما everyone's hoping everyone finds everyone well خلص اوكي I think انه فينا نلغيها لهيدا I don't see انه a point صارت redundant الله يسامح اللي بلش بس anyway some people might be fooled with this هلا you may be right يعني it could be controversial but one thing is obvious we are getting there is that we're not there yet the difference is have you ever used one of the older versions of chatbots يعني حتى من انا وصغير كان عندنا هيك تنزل it was good question answering اكثر decision tree based تسال سؤال بيجي على الارض not اكيد مش using generative models بس have you ever used anything like that غير ChatGPT
في سيري
I'm assuming you've all used ChatGPT
سيري قديمه
إذا سيري تعتبرها قديمة أوكي. It is بالنسبة ل ChatGPT you're right بس إنه different scales. سيري بس voice activated ما هيك مش.
إيه بس إنه الفكرة.
Right. بس إنه the idea is language specifically هلا is gaining much traction right so we're getting there but some people will still there are so many arguments against no okay this isn't really a test of intelligence. كثير اشياء ما حنفوت فيهم بس if you go هلا عم ياخذ AI ethics course do you talk about any of this ولا بس ethics؟ Okay so there are يعني but this is again this field spans multiple disciplines مش بس computer science and engineering and this is one of the areas where philosophy is heavily involved right what does it mean to be intelligent is human intelligence special from other intelligences can we actually replicate that etc يعني في كثير اسئله بتلاقيهم انه اليوم بتحس قصدت انه it's a bit foreign to the field ما بحس بالفلسفه ما بعتقد بيحكي عن binary search او بس انه when it comes to things like this we're touching upon problems that are beyond engineering and computer science anyway تعرف مثلا هذا this Chinese loom argument have you ever heard that the idea this is one of the thought experiments proposed by one of these philosophers that goes I'll try to remember it بس إذا في عندنا a sealed room with no windows no doors just a portal that we can pass a piece of paper through and we have someone sitting inside and that someone has a really huge manual of ways to convert English text into Chinese and بيوصل a piece of paper مكتوب عليها some English that person knows nothing about Chinese بس عنده كل الرولز قدامه بصير بده يفتحهم and knows how to map the words properly to Chinese and then pass the paper along and then over time this person memorizes this entire book and knows how to do it really quickly so حدا يجي يعطي له هلا بطل بلا ما يفتش اي صفحه دغري ويحطها so an outsider what does this look like like this person is comprehending what they're doing this person knows Chinese right and I don't care about the details بالنسبه لي عم مرق عباره عم توصلني Chinese this person knows Chinese right to the actual person inside they might know nothing about what they're doing so this is what's called competence without comprehension and that's one of the big debates in philosophy is this a matter of competence is the machine competent in what it's doing or is it comprehending what it's doing but yeah lots of things in that space these four guys were part of the Dartmouth conference so many things happened in this year one of the first algorithms related to neural networks emerged اللي اسمه the perceptron if you've seen that or if you come across it and that's when the term artificial intelligence was coined literally as AI in this field and they were overly optimistic and they thought the idea مش بس within a generation I think they have a snippet they proposed that a 2 months 10-man study يعني كان بدهم يخلصوها بشهرين للقصه كلها كان بدهم يعطونا one summer literally that's what they thought at the time can cover or make a dent into the artificial intelligence space obviously they couldn't have been farther but because of this announcement and so many others there became okay so كان في early successes to be clear alright so Eliza is one of the first chatbots if you want to look it up and see the difference between ChatGPT there was driver assisted كيف هلا بنشوف self driving cars ما كانوا self driving بس at least some assistance بالlane tracking وغيره as early as 1995. But because of the early successes, يعني when people started talking about this, كيف .com bubble, if you hear about this and the internet bubble, this was quickly overhyped. This cycle is not manna machine learning thing, it's called the Gartner hype cycle. So it applies to other things as well. But the فكرة إنه machine learning was overly hyped بالأول, and then quickly enough limitations came across. يعني بلشت العالم okay all of these يمكن زبطت معهم مرة بيشتغلوا فكروا إنه the entire thing will be solved. It did not take much for people to realize that that was not the case. And because of that, كل الاجنسيز اللي كانوا funding projects سكروا حنفية basically, and we had this first AI winter. So we had two of those actually. بطل حدا يشتغل يعني ما كان AI wasn't really a thing that was popular anymore. So it took a while until we got to this plateau of productivity. I think we're into a new cycle now. Can someone guess what's inflating هلا؟ LLMs. Thank you. Yeah, I think هلا وصلنا هون plateau of productivity. It was going well in 2012 onwards. Real research was being done, nice advancements. هلا فجأة again, I think it'll take a while before the wars then the big tech resolve. ونعرف what LLM to use in what task. Otherwise, everyone with money is training these, and there's a lot. ما عم نلحق يعني going around. نعمل experiment with one LLM في نهار فيها different versions. It shouldn't be that way, and that's not. Eventually, things will settle down. Let's give it time. Anyway, part of the reason, as some of you mentioned, is hardware and data. What kind of hardware specifically? GPUs. They all know graphics processing units. Originally, they were not done for AI, well for Bitcoin. Right? Their purpose was to reduce the load on the CPU for certain tasks that are computationally expensive and that can be offloaded to a specialized kind of processor. اللي هو الGPU. خلاص send these أكثر شيء الجرافيكس يعني for whenever مش بس in gaming يعني anything that has a graphics component. If you know anything about graphics, you know that see a lot of linear algebra, matrices, transformations, rotations. CPU بيهلك فيهم يعني. CPU has other things to do that are more general. And these tasks that were graphics related were somehow limited in type. يعني هن هالكم شغله عم نعمل matrix multiplication غيره. So a new type of processor was created just for these tasks originally. شوي some people were thinking, okay, since we have this piece of machinery, can we use it for other things if we choose to? And that's when something called GPU programming emerged. General purpose graphics processing unit programming. The language for that was CUDA on NVIDIA. يعني كان في كذا مش بس NVIDIA. بعض هلا مش بس NVIDIA بس NVIDIA took the market share. If you had stocks with NVIDIA من وقتها هلا, you probably wouldn't be here. بمزح you should be here لأنه ما حصل مصاري بس إنه anyway. So GPUs in 2012, some major updates were done in that space. Additionally, شو صار in 2012? Does anyone know? غير بس لأنه سمعوا القصة من قبل.
Moore's law.
لا Moore's law من قبل. يعني we've been hitting Moore's law and we've been going parallel for a while. But what popularized machine learning in 2012? Competition. So right. So there's a مش بس يعني there are many competitions that go around yearly, sometimes one every 2 years. One of these has to do with computer vision. So the competition uses a data set, widely known as ImageNet. فيها فوق المليون صورة. وهول الصور belong to more than 1,000 classes. Cats, dogs, trees, يعني so many different things. So it's one of the really big competitions in the computer space. And كل سنة يعني the top universities and top labs working in computer vision submit the newest ways of performing classification, and they publish papers out of it. It wasn't until 2012 that the first artificial neural network-based algorithm was submitted. I think it was called AlexNet. And it won by a significant margin, and that was enough to really boost performance and increase the popularity of the space. And that's when people started, that's why I say 2012 is the inflection point, because that's when people started taking it more seriously. I was still a student يعني then graduating okay كنا نحكي high performance computing was emerging غيره بس machine learning and AI was not as hot as it is now and it's not that long ago. But following this, it started becoming more and more. شفت Alex Matt شو عمل? It was, and that's why in the computer vision space there is a lot of support. And usually if you're working in that space في كتير products مش إنه خاصين بس you can quickly take some models off the shelf and start using them. They're more mature than other areas. This is training on tabular data or other kinds of data. GPUs, AlexNet, and the increase of data really led to the move of machine learning over the past decade. Does anyone have anything they want to share? إلا ما حتكون في class بس حاسس إنه في class. Any questions, any thoughts, any تفضل. ماشي الحال. طولت بقى اليوم جمعة. طولت اليوم. عفوا مايك. Alright. So what كلهم things you've seen or are familiar with, I don't want to spend time. You know some of the applications. I bet you can think of more creative ones in regression and in classification. Clustering. So this is again, you'll see this as you finish the specialization you're talking about. هتشوفوا clustering and other non-supervised learning based approaches. Here on the initial inspiration, so we said that the initial inspiration was modeling artificial neural networks based on how human brains work. Let's take some stats. In the human brain, there's about 100 billion neurons. Okay, each of these is connected to about 10,000 other neurons. So, as you want to calculate the number of parameters that the human brain has, these are the numbers you should use. Right? You know, usually machine learning and what you're doing is what's called parameterized learning. ما حنقول في شيء اسمه non-parameterized learning. That's not what we're talking about today. But the machine learning you're doing is parameterized learning. You know what parameters are? In linear regression, the logistic regression, what are the parameters? Size and the weights, right? So it's the way. What's the weight? يعني the weight of certain inputs. بكرة هتشوفوا إنه حتى بالneural networks في biases and weights. And these are again initially initiated based on models after the human brain. So the human brain عندنا 100 billion of these. كل واحدة فيهم يعني if you want to count the different number of connections, on average is connected to about 10,000 others. So it's huge. And when it comes to the artificial space, do you know when we crossed the one? I would say, do you know the scale at which we train? يعني ChatGPT كم parameter حدا بيعرف؟ 175 trillion لا.
هلا وصلوا.
Billion. 175 billion parameter. هلا they're working on the 1 trillion. They might have cracked the 1 trillion model, but I think I have a visible here. أول شيء ChatGPT كلكم تعرفوا. Do you know the actual version? يعني هلا إذا بتفوت what ChatGPT they use 3.5 و 4. هذا سأل عن 1 و 2. مش حرام؟ So 1 و 2 كانوا موجودين. They were known in the research community. Alright? But I don't think any of you used GPT-1 or GPT-2. Correct me if I'm wrong. Has anyone يعني إذا شيء بيكون حدا أو اثنين إذا عم تشتغلوا research in that field. Right? So why? يعني what's the main difference? Yes. هذا كان عم يقول شيء. They were. They could يعني they were used for research purposes. إذا مش هن غيرهم يعني don't focus مش بس على GPT. Language models have been there for a while. But what's the main difference between the early models and now? ولكن at the time scale يعني this is 2018 بعدنا لهلا أصلا ننسى إنه كان في كوفيد. right يعني بقول السنة الماضية تكون قصدي 2018 لأنه هال5 سنين معهم من حياتنا. But in this very limited time scale, what was the main difference there? The number of parameters. What's my? Tasks more specialized. Right. The goal is always to become more. The goal of machine learning is to generalize. At the day, we'd like to start with something specific that we know we can do well and take it further. But our way to get there, and this is what I'm trying to emphasize, the only thing we can do at this point, or what we seem to be doing, is scaling things up. And to some people, this is severely depressing. And is that all there is to intelligence? Just more cycles and more parameters and larger machines? خلصنا? And it's a bit dystopian. So we can actually crack general artificial intelligence simply by adding another computing rack and more parameters to the algorithm and all of that. But so far, this is what we've been doing. And well, from 100 million parameters to more than 100 billion parameters in the span of a couple of years. And the results were noticeable. Everyone suddenly started talking about ChatGPT, and AI became mainstream, finally. And now we're talking about trillion parameters and so on. Okay, but before that, when I used to show this slide a few years back, the largest model now hasn't even cracked the number of neurons in the smallest insect you can think of. These numbers are new. Okay, but another thing to keep in mind at the same time is how much power do you think we use as the human brain?
This is 20%
20% of the energy of it. Okay, so the brain does use a significant amount of power of the entire body. Most of the color intake goes there. But in terms of in terms of actual power, anyone as an estimate. Well, let me put it this way. Do you think a child learning language uses as much power as ChatGPT being trained on language? ChatGPT, right. Is that difference significant? Here. Let's try to put some numbers as an estimate. It's estimated that the human brain uses around 20 watts. بتعرف يعني 20 شمعة إذا بتعرف إنه اللمبة 100 شمعة 100 واط بيسموها. So 20 مثل اللاب اللي صغير super efficient. And it does all of this. Right? Including this talk and you paying attention much more. مع visual components. So it's really remarkable. ChatGPT uses the scales اللي حطوها بتقارن مع أي بلد. تستعمل training ChatGPT adds ما بعرف مثلا السعودية تصرف كهرباء بشهر أو whatever. These are the differences in scale. ثاني شيء, and this is, I was going to bring some books on language. It's fascinating. It's still debated what the origin of language was and how humans learned it to begin with. And if there's Noam Chomsky, if you're familiar with him, and his universal language machine. He thinks in every human brain has some built-in and installed machine that is there to learn language, بس we change the parameters بس يخلق الواحد. إذا خلق بالصين تعلم البارامترز ليتعلم صيني بيكتب من فوق لتحت، إذا خلق هون يكتب من اليمين للشمال. These are we fine tune that, بس the mechanism is there even though ما بنعرف وينها بالضبط. But his argument is a child does not see enough data to learn all this. There's not enough. حتى لو بنضل repeating the same word over and over, it does not explain this exponential burst in learning that we do. Compared to ChatGPT, what is it trained on? Do you know? Internet. بس شو الانترنت؟ قصدي بنقول نحن هيك كلنا بس literally if you think about what that means, كل ويكيبيديا, Reddit posts, everything you can put your hands on. So obviously there is a difference, and the difference is not just the number of parameters there. There is a difference in how we're doing things. So if our goal is to replicate human intelligence, obviously humans are doing things differently. So these are things that it's good to keep in mind. Is there a better learning paradigm we can think of? As you take the course, as you learn more about how neural networks work, while keep thinking about what needs to change here in order to be more efficient about this. حتى ما بقى أسمى بلد ضده أو غيره.
هي في شغله انه بنقول الهيومن لما يكون عم يتعلم اذا هتقدر عم يشوف باترنز بس الطريقه اللي عم يشوفها الكمبيوتر هي كثير غاليه. اذا كمان اعتبرناه انه هو عمليه اللي عم يشوفها كمان انه هو البارامترز عم يصير في نوع من
Right. So the way
كثير غاليه.
So but Steve, can we quantify that? And how does a human? How do you see data? See the visual component. Right? We rely on our senses usually. See the visual component. I'm looking at something. Usually it's mainly reading, right? The other ways as well. But all of these can be represented at the end of the day. And this is exactly what neural networks try to do. This is my representation learning. So there are differences in how the data are being collected. But so what? Okay, can we? Let's make artificial neural networks exactly learn as humans do. But can we at least make them more efficient at what they're doing? Can they not need a power plant and literally millions of dollars? This is المشكلة إنه to make it more exclusive. Not everyone. أنا وياك ما فينا هلا نعمل this kind of steps. Right? We'll need huge funding sources and machinery and other things in order to be able to do this. But عندنا مشكلة things بدها increasing. There's more work to be done. كثير عالم بطل عنده شغل أو their jobs are gone. There's more work. There's always the next update or upgrade to this. All right. So what do neural networks do? They gather input. Every neuron in our brain is connected to others. Every neuron connects input from other neurons. بتجمعهم بطريقة. It does some calculation and then produces an output to other neurons. That's all this. That's the mechanistic representation of an individual neuron. It's an entity that aggregates input, and based on that aggregated input value, it either fires up a signal or it doesn't. And the strength of that signal differs. That's it. And we have billions upon billions of these doing that at the entire time. And that's what we try to replicate in these artificial neural networks. Each of these represents one of these neurons. And the edges are the connections. So every one of these neurons here is accepting or aggregating input from some group of neurons based on the values aggregated and some calculation done here. This neuron will either output a value or the output the strength of the value, the intensity of the value changes. That's literally it. And that's why some people don't like these kinds of algorithms. It's not exactly clear what's being learned in these intermediate representations here. Okay, few numbers going in, other numbers going out. What's being learned in between? What's the representation that is happening? That's why they hear the term black box. Neural networks are looked at as black boxes compared to what? Compared to decision trees. You don't know decision trees, but you will. Keep it in mind. And when you learn about decision trees, the learning process is clear. It's like the 10-question thing. You literally ask a question about the data. So yes, you split the data based on that value, and so on. خلوها ببالكم هتشوفوا the difference between decision trees which follow a clear path of decisions to reach a conclusion and this which really do not follow a clear path. We don't know exactly what's being represented in the middle to get there. But see advancements in this space. So this is what a model neuron looks like. I want to get a bit technical here. That's to show you why neural networks. And we've said before that there's artificial intelligence, there's machine learning. We zoomed in on machine learning and we're talking about this. And then there's deep learning. Why is all the hype and all the progress happening in deep learning and not the other algorithms? Why isn't logistic regression enough? Does anyone know? Does anyone have an answer? What's wrong with the algorithms that you've seen in course 1 منه less specialization منه 1 course وهلا خلصت in 4 weeks. ما أقدر أتحل كل شيء. طيب, so this is do you think neural networks قادرين يحلوا كل شيء؟ لا قادرين. هلا there's the reason the way you said it is interesting. Neural networks, there's something called the universal approximation theorem for the math in you and the audience and the others. I advise you to look into that. So there is a theorem that actually states that an artificial neural network can approximate any continuous function to arbitrary precision. بس هون بنحط مثل asterisks certain conditions and rules of mind. In artificial neural networks, تعرف شو أنا hyperparameter معي? Learning rate, number of iterations. These are things you're changing to tweak the learning performance. I say some of the two important things in an artificial neural network in the size. بعد عم نحكي عن number of parameters. The larger the network, the more its capacity to learn. Right? And then this size is split into two. لأنه we can مثل ما شايفين in the previous slide. This is called a layer in an artificial neural network. Right? Theoretically, how many layers do we need in order to learn and approximate any continuous function? 1. في عندنا the input فيكم سموه input layer بس هي just the input. Alright? في عندنا the output. كمان you can call this the output layer. But the actual layers where the learning is happening is in between. شو اسمه hidden layers. Originally كنت قلت شو هالترم what are they hiding from بس الفكرة هي إنه ما لهم input ولا بالoutput. We don't directly see them. Alright? So we need at least one hidden layer in order to be able to approximate any continuous function. In reality though, practically speaking, having more layers produces better results in most of the cases. Then as a one hidden layer, we might need a lot of neurons in that layer. You can't always afford that. So what you will see during the course, again, هولي يعني عم بحكيهم بسرعة. I know they might not make so much sense to you, but when you see them, I hope you can relate the concept together. What you see is neural networks are structured as one layer after one layer after one layer, and so on. Every layer learns from the previous one, a combination of features. So this is what I want to focus on now, and this is why logistic regression is not enough. I will say logistic. What kind of model is logistic regression?
One layer, one neuron.
One layer, one neuron. I want a keyword. I'm looking for a certain word there. What does the function that logistic regression learns look like? A straight line. Right? So what kind of? It's a linear model. Right? This is the main limitation here. We have some data that we're trying to distribute. Linear regression can learn something like this. So, whatever we're trying to fit, the linear regression model will learn a straight line to fit the data. Does that always work in your opinion? Most data actually that we work with is non-linearly separable. And a straight line is not enough in order to separate the two classes. There's again a classification task I'm explaining. So it follows a different distribution. And mathematically, this is why we need neural networks. Neural networks are non-linear models. And that's how we can approximate any continuous function using them. But how does it work? Logistic regression has one layer, one neuron can learn, let's say it can learn one feature. Before, so this is what a neural network looks like. We have the input, we have one hidden layer, after one hidden layer, and the more hidden layers we have, the deeper the network is. That's where the term deep learning comes. Tell me how deep is deep, ما حدا بيعرف. It depends on when you ask the question. But من كم سنة لورا 15 layers, that's a deep model. هلا ممكن نبلش. It's a bit again controversial. But we have networks now that are hundreds of layers deep. Right? But deep learning refers to artificial neural networks with an enough number of hidden layers in between. That makes the network deep. Okay? All right. So what's happening inside those layers? I want to add a slide here. In computer vision, the hello world example is hand digit recognition. Have you seen this? So you use images of handwritten digits and try to classify which digit it stands for. And I used to show this slide as an example of how little code you need in order to do it. And if you want to do it today, I think you need help code. And this is, you literally need a line to import the library, another line to import the model, and a third line to fit train. So you can do this in much less code than what's shown on these slides. Unless you're implementing the actual functions yourself. Yeah, this is what this is doing. Anyway, so what does every layer in a neural network learn? I'm going to give this example from computer vision, and it's sometimes easier to think about. Let's assume that the task we're trying to solve is detecting whether there's space in an image. Your smartphones today there's some box around it. Right? In a rule-based method, how would we do that? يعني انسوا machine learning, انسوا data-driven models, انسوا كل شيء. If you were a programmer trying to solve this problem, how would you solve it?
A face has two eyes and all.
Right, so there are components in a face. So you slide a window, right? So you start looking in a certain area for a nose. How do you know if there's a nose?
بنشوف النوز من شو composed.
Exactly. So you keep breaking down, right? If you want to look for a face, you look for the components of the face. This could be eyes, nose, lips, and then each of those will need to be broken down enough until you actually hard code it there. That's you're looking for a certain shape, a circle, doing that. You can imagine how much code that would take if you want to. And even then, if you do that, it would not generalize well. يعني يزيد 11 شوية الواحد, the program would fail. Otherwise, you have to hard code them in different angles, different values, right? So, how does machine learning do that?
بتكون مناقشه كل شوي بتصير كثيره.
لا, but what does it need in order to learn what the face is? Data. أعطيها جمع عدد ما فيك صور faces. The machine learning model, using something very similar to gradient descent that you've seen, will learn to extract the relevant features that make a face. To us, we hope that what it's looking at are the eyes, the noses. We think, and only we conjecture, we hypothesize. Do we actually know? Not really. Again, there's work on interpretability. So we can now peek into what the model is looking at. So and when it comes to computer vision, again, so much effort is being invested in the space, so we can actually look at what the model is considering to make decisions. But generally, and for a long while, we had no idea what's going on inside. But we hope that this is kind of the features that are being learned. An eye in the top left, an eye in the top right, a nose in the middle, lips in between. Yes.
Do I actually need to know I assess the model?
Good question. When do we need to know that? حسب إذا your goal is simply to create a program that can predict faces, you know. So you simply measure its performance. If it's doing well, sell it to the highest bidder. But if your goal is you're predicting whether a patient will develop or has cancer, you do need to know. Otherwise, if you take this somewhere, you won't get the necessary approvals to actually implement it or deploy it. So why do we need interpretability? How is your accountability? So in order to build trust with the model, and in order to deploy it. يمكن تسلا فات بالسياره اللي قدامها حتى ما تخبص حدا نط things like that يعني these incidents will happen. So whenever your program touches the real world, we need to be able to explain how to show that we understand why a certain decision will be made and to explain it. To improve it كمان يعني understanding sometimes في indicators مش من data. We can actually, again, in computer vision فيها methods, we can use heat maps. And it shows us where in the image was the network looking when it made this decision versus when it made another decision. مثلا. But what's the point I'm trying to make here? In a multi-layered neural network مثل هيدا, the way the network learns is, so here we have the input. In an image, what's the input?
Face.
Pixels. So the pixels are fed into the network phone. And then each one of these acts like a logistic regression model. That's the most simplistic view we can have of this neural network. So each one of these is learning a combination of the pixels that we passed from the previous layer. And the first combinations, what can first combinations be? And إذا أعطينا pixels, a group of pixels here to each of these, what do you think a neuron like this can learn?
واحدة للآي واحدة للنوز.
Edges. يعني the first combinations will be something simple. We're trying to learn higher order features, right? So here مثلا يمكن هذا يتعلم a certain edge. What about this one? كمان we need some linear combinations. حيكون اشياء صغار يمكن colors, the intensity, whatever it is. طيب. Every one of these neurons will learn some basic, still more complex features than what was fed, but still basic enough. بعضنا لأنه بالearly processes. The magic behind neural networks is we have multiple ones of those. So each one of these features that are now learned will be the input to the next layer. So this layer here, what is it connected to? The previous layer. So what will it receive as input? All the combinations of pixels, the features that were learned in the previous layer. So now, what can this neuron learn out of these combinations? Shapes. يعني لو هي تعلمت edge وهيدا edge وكمان هيدا edge وهيدا edge. What can this one learn? Something like this. It can put things together. This neuron here will learn the function of the pixels that were first input into the neural network. The deeper we go here, if we had a third hidden layer here, it can learn even more complex features. Eventually, you can imagine if we have a deep enough network, what started as simple edges and combinations, نوصل لمطرح هون يمكن يصير an ear. أنا ما قصدي بالرسم بس you can imagine how if we group enough basic features we can model an ear. And other neurons can model the nose and things like that. And then the last layer can put these together. بتجمعهم. يعني a function is عندنا neuron that can learn an ear, another one هذا nose مفروض, and another one lips. What do we need? بدنا neuron that can learn a function of these. It puts them together, يطلع عندنا the entire face. So that's how neural networks work. Every layer learns a function of the features presented by the previous layers. At the very first layer, the input layer شو عندنا? The raw data. The first layer learns some combination of this, learns a feature out of this raw data, and then passes these new features to the next layer. And then the next layer learns even more complex features. It's a higher order of features. And then this keeps happening until eventually we get to the last layer. Do we want to learn more complex features? Increase the number of layers and the number of neurons. Do we want to simplify? حسين our network is overkilling it. We can reduce the number of layers and the number of features. It depends on the data we have, and it depends on how non-linearly separable it is. How non-linear the data is, basically. If the data was linear, there is no need for this. Right? So, and this is something, I'm نحط كتير اشياء, but it's one session. It's one session. In many cases, a lot of the applications that are using neural networks don't even need to. Logistic regression would work. بس هلا people خلص neural networks, deep learning, they start with neural networks. ولا بلا معذب حالي يعني بالذات. But if data is linear, you don't even need neural networks. Is that clear?
Yes.
So, what this is called is representation learning. All right? If I want to use if I want to use logistic regression to achieve the same goal, شو لازم نعمل؟
And logistic features.
لا ما هو يعني you can think of neural networks as multiple logistic regressions. بس مش many features. اخر شيء output لا.
more than one problem. يعني واحد شغلته مثلا هون انه بدي موديل يلقط اذا في اي.
That's not what I'm going for. Have you talked about feature engineering?
Yeah.
Yes. So the main premise, and if you want to take one thing out of this entire session, let it be this one. The main difference, or the main motivation, or the main power of neural networks is the following. في عندنا احتمالين. If I have data that's non-linear, either you bring a human brain to determine the set of features that we need to use in order to reach a certain decision. And one of the examples I think Andrew gives is I want to predict the price of the house based on its dimensions. فينا نعطيه الطول والعرض. بس usually هون إذا بدنا نبيع عرض أو بدنا نبيع بيت شو بنسأل؟ مساحة. إذا حدا أعطانا الطول والعرض as a human what do I do؟ بضربهم ببعض. I calculate the area and then based on the area معي price per square meter and I get the price. Right? So في عنا two options. Either we bring a human specialist that looks at the data available, eliminate the dimension, and then comes up بمعنى ثاني engineers engineers features, right? So comes up with new sets of features that are better suited for the problem, more relevant. In that case, إذا بعطي هالarea a logistic regression model, it can learn the relationship بين الarea والprice. بس من بعد شو؟ من بعد ما a human engineer the features. And that's very effective, that's very powerful, and that's very demanding. I will see in many problems, we don't even know what the features necessary are. كتاب شوي عن cancer. ما عندنا بعد knowledge enough in this space. But what do we have? Data. So شو البديل عن bringing a human؟ بعدين هلا human بيجي بيطلع برقمين بيطلع بالاريا بيناتهم، بس إذا عندنا a million of those ما بدي يعني ما منا شغله. Right? So the alternative is an artificial neural network does that. And that's the power of neural networks. Automatic feature engineering. What's the input here? هذا اللي بدي أركز عليه. Raw data. مش feature engineer data. It just takes data as it is. And the power of this is that's the premise على الآلية. And the neural network will learn what features are necessary on its own. All right, through an algorithm called backpropagation. The algorithm طلع بال80s نسيت اي سنه بالضبط. بس كمان that was one of the reasons why machine learning came back into the picture. It's largely similar to gradient descent. You know gradient descent, right? That's very similar. كمان you know calculus, so you know the chain rule. Do you know the chain rule? Yes. So it's based on that. يعني it's a method in order to train all of these and like what I thought. Efficiency. Backpropagates an error throughout the network. So if I want to summarize, what do we need in order to achieve artificial intelligence or to train models like this? And I've put it under 4 pillars. We need an agent that can output something that humans can comprehend. Do we have that? Can we understand what computer programs output? Yes. يعني بس يطلع output numeric أو language, we can analyze that. So good. So عندنا communication channels between us and artificial agents. So ثاني شيء, we need a way in order to tell how good or how bad an agent is. Do we have that? Just what do we use to do that? Cost functions. So that's the second pillar we need. We need a way to measure how good something is. What's the third thing? ما بيهمنا إذا بس واحد شغل في عالم بس بتقول عن واحد بتقول إيش اللي ما عجبك but they don't offer advice on how to improve. Don't be those people. In terms of training machine learning شو بدنا؟ نحسن. We need a way to improve someone that's not doing well. Do we have that? Yes. يلي هن gradient descent and you will see backpropagation. رابع شغلة. أعطيه data بشكل عام. يعني كل هول ما بينفعوا إذا we don't give the agent the ability to make mistakes to learn from. So we need examples that the agent can learn from so that we can assess how good they're learning and improve it along the way. All right? I think that's all I wanted to say on the matter. إذا عندكم أسئلة عندكم anything, we have some time.
بس ما كمان we don't know what features it's focusing on.
Right. But that's why that's the point. It automatically learns features, but we don't know what the features are. Yeah, you can see them, but we don't know what they stand for, what they look. It's not quantification that's the problem. You can see what the feature is. What is this exactly? What does it represent? What are we looking at? It could be. It could be.